In this lesson, we're going to look at exponential growth and decay. Any function of the form y equals ab to the x, where a is not equal to 0 and b is larger than 0, and b is not 1. There's a lot of little details there. If a is 0, it just zeroes out the whole thing. B needs to be a positive number, but not 1. If b is 1, then the x power is really not doing anything, because 1 to any power is just 1. So if all this is true, then we've got an exponential function with base b. If b is greater than 1, the function is exponential growth, and if b is the growth factor. So we're going to graph in this example y equals 2 to the x, just to get an idea of what one of these functions looks like. So let's just do a table of values. Let's choose some x values, some negatives, 0, and some positives. If we put in a negative 2, 2 to the negative 2 is 1/4. Negative 1, 2 to the negative 1 is a half. 0, 2 to the 0 is 1. Put in 1, 2 to the 1 is 2, and put in 2, 2 to the 2 is 4. So if we get a graph of these points and then kind of connect in the dots or use a graphing calculator, we'll get the graph there on the screen. So it's an exponential function. Notice how it kind of takes off. And the way I remember what this graph looks like is it's got kind of an X Games type ramp look to it. In this example, we're told that the world population in the year 2000 was approximately 6.08 billion. The annual rate of increase was 1.26%. We're supposed to find the growth factor for the world population, and then suppose the rate of increase continues to be 1.26%. Write a function to model the world population growth. Well, the growth factor, if it's 1.26%, then the growth factor is 1.0126. Here's the 1.26% here, but it's going to keep its total plus another 1.26%. So every year it's going to be 101.26% bigger. That's why you see 1.0126. The function for that, well, its initial value was 6.08 billion. And its growth factor, 1.0126, the b value, is growing at 1.026 per year. X equals 0 would be the year 2000. So if we put 0 in here, this is all 1. 1 times 6.08 gives me the 6.08 billion. So this number up front is always our starting value. This number inside here is always our growth factor. If it's larger than 1, we're growing. If it's less than 1, it's decreasing. We're going to write an exponential function in the form of y equals a b to the x for the graph that includes these 2 points. In order to do that, we're just going to use the information. When we're looking at the point 2, 2, when x is 2, y is 2. So we get 2 equals a b to the 2. If we try to solve that for a, we'd have to divide both sides by b squared. So a is the same as 2 over b squared. That's about as far as we can go with the point 2, 2 by itself. So now let's switch over and use the point 3, 4. When x is 3, y is 4. When x is 3, y is 4. We already know that a is 2 over b squared, so let's go ahead and put that in. 2 over b squared goes in place of a. If I have b to the third divided by b squared, I can just reduce those and get b. So now 4 equals 2b, therefore b has to be 2. And once I know b is 2, I can plug that back in over here and find out what a is. Actually, they went all the way back to here. I would have put it in here. So we put in 2 for b, a times 4, or 4a equals 2, and a equals a half. We'd have seen it quicker here. 2 over 4 is a half. So a is a half. So now we have to just write the function in this form. I know that a is a half, and I know that b is 2. So we'll just go ahead and write the answer. Y equals a half times 2 to the x. And there's our exponential function. It definitely contains these 2 points. You try one of those. Go ahead and pause the video. Give that a try. When you're ready to check your answer with mine, press play. Okay, here we go. I would first plug in the 1 and the 5. So the 1 goes in for the x, the 5 goes in for the y. So I've got 5 equals a b to the 1. Therefore, a would always equal 5 divided by b. So I've done everything I can do with 1, 5 so far. Now 2, 7. When a is 2, y is 7, so a equals a b to the 7. But a is the same as 5 over b. So 7, oh, not ab to the 7. I want ab to the 2. So 7 is equal to a, which is 5 over b, times b squared. But notice how this just reduces out. I can knock a b out here, brings that down to a 1. So 7 equals 5b. And b is going to equal 7/5. Okay, so I've got b. Now I need to go get a. And if I go back over here, I know that b is 7/5, so I've got to take, this is the same as saying 5 divided by b is equal to a. So 5 divided by 7/5 should equal a, or 5 times 5/7 equal a. So a is 25/7. So my function is y is equal to a, 25/7 times b, 7/5 to the x. Now this is looking kind of funny, so I'm going to check this just to make sure. So when x is 1, I'm supposed to get 5. When x is, actually that's 27. Ooh, boy, I'm glad I'm checking this because it's 25/7. So let's rewrite that. Y equals 25/7 times 7/5 to the x. Let's get rid of that other one and still check it. When a is 1, I'm supposed to get 5. So I've got y equals 25/7 times 7/5 to the 1. Well, 7/5 to the 1 is the 7/5. That reduces out. 25 divided by 5 is 5. So that point checks in. Let's make sure the other point checks in. When a is 2, I'm supposed to get 7. 7/5 squared. Well, if I square that, that's the same as 25/7 times 49/25. Notice these go out, and 7 goes into itself once and into 7 times. So that does equal 7. That checks also. So even though that's a funny looking answer, 25/7 times 7/5 to the x, that is the right answer. You can always, always, always check these. How'd you do? Here's another one for you to try. Go ahead and pause this and give that a shot, and then press play when you're ready to check it. Okay, here we go. I've got -2 and 9. So when x is -2, I'm supposed to get 9. So that's y equals, actually I don't want y in, I want 9. 9 equals ab to the -2. That's the same as 9 equals a over b to the 2, right? So if I'm trying to get a by itself, I'm going to multiply both sides by b squared. So 9b squared is the same as a. So there we go. And then for 0, 1, when x is 0, I'm supposed to get 1. So 1 equals a b to the 0. Well, what is b to the 0 though? It's just 1. So 1 equals a. So a is 1. So in this case, I know that a is 1, so I can go take that back over here. I've got 9b squared equals 1. I can divide both sides by 9 and square root. So b would equal plus or minus the square root. That would be 1/3. But remember, b has to be positive for these to work. So I can throw out the negative. We're just going to keep the positive 1/3. So my answer should be y equals a, which is 1. We'll go ahead and write the 1. Times b, which is 1/3 to the x. Let's give that a check. When I put in 0, do I get 1? Absolutely. 1 times 1 is 1. When I put in -2, do I get 9? If I put in -2, that means I've got to flip this over and get a 3, square it. That's 9 times 1 is still 9. Yeah, it checks. So that's right. It can't be wrong. How'd you do? Here's another one for you to try. We got some ugly looking numbers, but go ahead and pause that and give it a try and see how you do. All right, let's see. When x is 2, I'm supposed to get 122.5 when x is 2, so that's ab squared. So that means that a equals 122.5 divided by b squared. Nasty. When x is 3, I'm supposed to get 857.5. Again, not pretty numbers. So let's see what we get here. We get a times b to the 3. Well, I know that A is 122.5 over B squared, so I've got 857.5 is equal to A, which is 122.5 over B squared, and that's times B cubed. Notice what happens here again. We get a nice reduction in these guys. So 857.5 is equal to 122.5 times B. So if I just divide both sides by 122.5, I should get an answer for this B. So on my calculator here, I'm doing 857.5 divided by 122.5, and my result on my calculator screen says that B is 7. That's kind of a nice answer to appear. Well, if B is 7, let's see what we're getting over here. A is going to equal 122.5 divided by 7 squared. In other words, 122.5 divided by 49, and that says it's 2.5. So A is 2.5. So the answer I just got is y equals A, 2.5 times 7 to the x. We should probably check one of these. Let's try taking 7 cubed and 7 to the third power on my calculator times 2.5. What did I get? I got 857.5. I'm pretty confident that that's right. So I'm going to go ahead and say that's my final answer. How'd you do? All right, now let's take a look at exponential decay. Exponential decay is modeled by the same function. The only major difference here is that b is not greater than 1. It's between 0 and 1. Okay? It's between 0 and 1. So a is always going to be the starting amount, and b is the decay factor this time instead of the growth factor when b is between 0 and 1. So without graphing, determine whether the function represents growth or decay. Well, since b is less than 1, this has to be decay. What do you think? Growth or decay? Right, that's right. You should say decay because b is less than 1. How about this one? Growth or decay? Well, b is larger than 1, so we better say growth. Growth or decay? Well, 0.5 is smaller than 1, so we should say decay. Here's an example. Since 1980, the number of gallons of whole milk each person in the United States drinks each year has decreased 4.1%. In 1980, each person drank 16.5 gallons. We're supposed to write an equation to model the gallons of whole milk each person drank, and then use the equation to approximate consumption per person of whole milk in 2000. I think, yep, I got to script this one out. Okay, so here we go. Let's get the important stuff here. Decrease 4.1%. So there's decay going on. Each person drank 16.5 gallons per year in 1980. So that's a starting amount. Write an equation to model it, and then we got to do a prediction. So let's see if we can do an equation to model this thing. So let's see. I'm decreasing 4.1% per year. So that means if I had 100%, it wouldn't decrease, it would stay the same. But if I take 100 minus 4.1, I get 95.9. So this is going down at 95.9% per year. So I guess that's not going down by that much. I said that wrong. What I've got left is 95.9%. If I start with 100%, I go down 4.1%, I've got left 95.9% of what I had. So my function is y is equal to my starting amount times my factor here is 0.959. That's the 95.9% that's left after the 4.1% decreases at the end of the year, and that's to the x power. So there's my function. Now they want me to do a prediction. They want to see how much milk people were drinking in 2000. Well, this is for when x equals 0, x equals 0, that's the year 1980. So what would the year be in the year 2000? Well, x would have to be 20. So if I just check this out, I would say y is equal to 16.5 times 0.959 to the 20. And go ahead and throw that in a calculator. So 16.5 times 0.959 to the 20 power. And what I'm getting is about 7.14. Did it say where to round? It did not say to round. So in the year 2000, we're doing approximately 7.14 gallons of milk per person. That should be of and then per person. Gallons of milk per person. So I've got my function and I've got my prediction for the year 2000. Here's one for you to try. Suppose the population of a certain species has decreased 2.4% each year. Suppose there were 60 of these animals in 1999. Write an equation to model that, and then use that to predict how many there are in the year 2005. Go ahead and pause the video and give that a try. See how you do. All right, here's my solution. If I'm going down 2.4%, that means I'd start with 100%, I'd subtract 2.4%. What I'm going to be left with is 97.6%. That's 0.976. So I'm going to have, that's my decay factor to the x. And I started out with 60 of them in 1999. So y is going to equal 60 times 0.976 to the x. Now they want to know what's going on 6 years later. We go from 1999 to 2005. So in 2005, there should be 60 times 0.976 to the 6, because that's 6 years later, of these animals alive. So let's see what that is. I've got my calculator here. 60 times 0.976 to the 6th power. I'm getting about 51.86. So let's call that about 52 animals. So I've got my prediction for 2006 and I've got my function, both things they asked for. How'd you do? Okay, shift gears a little bit here. They just want to know what's the percent of increase or decrease in the function. So if it's 1.3 is the growth or decay factor, first of all, you need to recognize that's growth. What's the percent of increase? Well, it's going, this is 130%, right? So I get my whole 100% back plus 30% more. So that's a growth of 30%. So it's a 30% increase is the way we're going to answer that. What do you think for this one? Isn't that 170% total? So isn't that a 70% increase? How about this one? Notice it's only 0.25. So how much did it decrease? From 100% down to 0.25, it went down 75%. Without graphing, just determine if this is growth or decay. So this problem, what do you say? Better say growth. It's up 63%. How about this one? Decay. Right. And obviously growth, we've already seen that function, and decay. Oh, we got another one here. That one is good, growth. That's our learning target for this lesson. I'll see you in class.